So remember, the idea of linear regression is trying to fit a line to a set of data. And the first step in that process is graphing the set of data, and that's what a scatter plot is here. So let's look at some scatter plots. So here we've got a pattern that goes from lower left to upper right in the data, and it looks like that data is pretty close to being on a line. So there's a candidate line there. So since as x increases, y increases, lower left to upper right, we call that a positive linear pattern. Linear because they're close to a line. And that's strong because they're really close to a line. Here the data go from upper right to lower left. So in that direction. So as your x increases, your y decreases. So here as x increases, your y decreases. Where here as x increases, y also increases. So that's positive. This one's negative. It goes down left to right. And then these points are really close to the line, so that's going to be a strong pattern. Now this one channels from lower left to upper right, but the data are not really close to any one line. So we would call that a positive linear pattern again, but it's weak because they channel from lower left to upper right, but they're not close to one line. And then same thing over here, but negative linear pattern. So these channel from upper left to lower right, but they're not really close to one line. So it's a negative linear pattern, but weak. And then here, they just seem to be random dots. There's really no pattern going on there. There's no one line that would really fit the data well. So let's go ahead and construct a scatter plot here for data relating Netflix subscribers and revenue. And then we're going to assess the direction and the strength of the relationship. So here we got subscribers in millions. And then we've got revenue in billions. So subscribers is our X and revenue is our Y. So 0 to 200 on the X here, and then 0 to 25 on the Y. So when X is about 24, Y is 3. So this would be 20. So 24, 3, about right there. When X is 30, Y is 4. So 30 and 4, getting a dot close in there. 41 and 4, so 41 just to the right of 40, height 4. 54 and 5, so this would be 60, so 54 would be almost to that 60, go up to 5, about right there. 70 and 7, so this would be 60, 70 would be halfway between this mark and this one, and then 7, about right there. And then 89, so about 90 and 9. So 90 would be here, going up 9, about right there. Then 110 and 12, so 110 to the right would be here, up 12, about right there. And then 139, so about 140, and then up 16. So 140 to the right on this line, up 16, be about right there. And then 167 in the X, 20 in the Y. So 167, about right here, up to 20 in the Y, about right there. And then 203 in the X, 25 in the Y. So 203 just past the 200, go up to 25, about right there. So that's our scatter plot. And it looks like these values would be fairly close to a candidate line. That might be a candidate line. So I would call this positive relationship because it goes up from left to right, and then also strong. So this is a positive, strong, positive, linear relationship. And if those were spread out more from the line, we could say that it was maybe a weak relationship. So, and later in the chapter, we'll actually have a numerical measure to assess how strong the relationship is, and then also to find the best line that would represent or estimate the data.